The body actually has 4 different battery packs because the human body is a portable electronic device. Like all electronic devices, it has to have a battery pack. Largest one of all is our muscles. Now, our muscles are piezoelectric, and for those of you who aren't physicists, that funny word piezoelectricity means that if you stress a substance and it emits electrons, that's called piezoelectricity. So when I move my muscles, I'm generating electrons, which is, by the way, why exercise is so important, because exercise is the way the human body is designed to recharge your own personal battery pack. But the reality is also that our muscles are rechargeable batteries. And so we have then these large muscles, which are our main batteries. And then these muscles, battery packs, are all hooked to our cell membranes. Now, cell membranes are capacitors. So what is a capacitor? Well, a capacitor is a small battery. And the way our cell membranes are designed is with a couple of opposing layers of funny fats called phospholipids. And these fats have a ball and then 2 legs. Well, the balls are electron conductors and the legs are insulators. So when you put them like this, you have 2 conductors separated by insulator, which by definition is a capacitor, which means it stores electrons. And then inside the cell, we have mitochondria. And inside the mitochondria, we have another rechargeable battery system. When that battery system is charged up, we call it ATP, and then as it gives away its electrons and discharges, we call it ADP. Well, because we have a rechargeable battery system inside our mitochondria, guess what else we need in there? A battery charger. And the battery charger inside the cell is called the citric acid cycle or the Krebs cycle. So the Krebs cycle runs on primarily fatty acids, and so as you put fatty acids through the Krebs cycle, it creates electrons. And for every unit of fatty acids that you put through the Krebs cycle, if oxygen is present, you get enough electrons to charge up 38 of these ATP batteries. Now, in addition, we have the DNA. Now, DNA inside of our cells, we generally tend to look at it from the side, and we look like we took a couple of step ladders and twisted them. But if you look at it from the top, it looks like this. And every circle of DNA is golden mean, and what that means is diameter is 1.6 times the height and so forth. And any place in the universe where there is something that's golden mean, or in the shape of a platonic solid, it will cause implosion of scalar energy. So because our DNA is golden mean, scalar implodes into it and gives it its charge so that it has the energy to do its job. Our muscles then are stacked one on top of each other in a very specific order, like stacking batteries in a flashlight. And so surrounding this stack of muscle batteries, we have a substance called fascia. Now, the interesting thing about fascia is that fascia is a semiconductor. It's a collection of molecules arranged in such a way that electrons move through it at the speed of light, but only in one direction. So we have then this continuous stack of fascia going from our toes up to our brain, or from our fingers up to our brain, and surrounded by this stocking, which serves basically as the wiring system for the body. Every organ in the body has its own battery pack. Because every organ in the body has its own battery pack, then we have the ability to isolate, measure that voltage, and figure out why that organ's malfunctioning. A stack of muscle batteries is what's been called an acupuncture meridian. So an acupuncture meridian is simply a stack of muscle batteries. And one of the things that resonated to me with those various books was that each one talked about the fact that cells are designed to run at a pH of 7.35 to 7.45. And so the reality then is voltage in a liquid we call pH. And by convention, if you find that the solution is an electron stealer, you put a plus sign in front of the voltage. And if it's an electron donor, you put a minus sign in front of it, and then you convert the voltage that you measure with a logarithmic scale going from 0 to 14 and call that pH. So plus 400 millivolts of electron stealer is the same as a pH of 0, whereas minus 400 millivolts of electron donor is the same thing as a pH of 14. And if it's neutral, if it's neither electron donor or electron stealer, then that's a pH of 7. So when we say that cells must run at a pH of 7.35 to 7.45, we're saying cells must run between minus 20 and minus 25 millivolts. Well, that was a wowzer for me. Guess what? Cells need energy to work. That makes sense. But in the environment of this body, they're designed to run at minus 20 to minus 25 millivolts. Essentially, all chronic disease is that you have low voltage going to that organ. We are constantly wearing ourselves out and having to make new cells. So the macula in your eye today is only 48 hours old. In other words, you get new cells in the macula every 48 hours. The lining of your gut is 3 weeks old. So we are constantly wearing ourselves out and having to make new cells. So it turns out then that chronic disease only occurs when you lose the ability to make new cells at work. Let me say that one more time. Chronic disease only occurs when you lose the ability to make new cells at work. Well, if that's the case, then we need to ask the question, what does it take to make a new cell that works? Well, as I mentioned, it takes minus 25 millivolts for a cell to run, but to make a new one takes double that. It takes minus 50 millivolts. And then in addition to having the voltage to make new cells, we have to have all of the nutrients.